So in this module, we're going to focus on time and temporal data. This is a relatively new thing in GIS, being able to handle temporal data in an effective way. And essentially what we're doing is adding an additional dimension to the map. So it makes it even harder to represent, particularly in sort of a flat, static map. There are lots of different types of data that we deal with when we're dealing with temporal data, because there's lots of different things that can change over time. Now, most of what we're going to work with is going to be vector data, changes in vector data over time, though we're going to focus a little bit on at the end here about how to represent changes in raster data over time. So the first thing we need to think about is what is changing and how is it changing in some sort of spatial temporal context. Now, this could be points, this could be lines, it could be polygons, it could even be volumes. So for example, a point is probably going to change continuously along a line, whether this is something like a track log or whether this is simply the location of, say, a radio collar on an animal changing periodically throughout the day. Now we can also, if we're looking at areas, we could be thinking about evolution of an area in either size or shape. So a particular area, whether it be, say, urban sprawl or decreasing forest cover, could be getting bigger relative to other things. It could be changing its shape entirely. We could even be getting things where we're seeing changes in the number of occurrences, where we might have what was previously one forest that gets fragmented when someone puts a road through it. And then over time, this could even, one of the two sections could move around a little bit, and they could even merge back together. So as you can imagine, when you're building something like this in a GIS context, having the ways that those vector data interact with each other when they're becoming different features and then merging back together can be pretty complicated. Now, there are lots of different ways we can illustrate time on a map as well. These can be as simple as a single kind of static map that shows something temporal, whether it be change between two different time periods. So this could be, here's a very famous one showing ancient courses of the Mississippi River. This is by the U.S. Army Corps of Engineers from the 1940s. And you can see what it's showing here is it's showing something temporal. It's showing the different paths that the meanders along the Mississippi River have taken over sort of recorded history. But it's not necessarily showing them as a slice of time. It's showing them over time colored differently. So we see the current one, or the 1944 path of the Mississippi in sort of white, and then other time periods shown in different colors. We can also show something statically with time in there by showing differences between two time periods. So in this case, we're seeing population change between two different time periods, so an increase or decrease in population. Now, a lot of these spatiotemporal visualizations are based on a very, very early map that I just want to present because it's a really kind of cool one here. And this is from 1861. This is the Charles Minard map of showing sort of Napoleon's path towards Moscow and then back. So it's showing both time, it's showing weather along the bottom, and it's also scaled to be showing both the geography of where the troops went, but the line itself is scaled to how many or how large the army was at any given moment. So you can see it's very, very big at the beginning. As they're going out towards Moscow, it's getting smaller, slightly smaller as battles are fought and people are lost to the winter weather. After the battle, it's extremely small, and it just gets even narrower and narrower and narrower as we're moving backwards. So these are interesting ways of showing time on a static map. Now we can also show time by looking at a series of static maps, so a time series, if you will. So this could show something like how a country or a state's borders have altered over time, or how natural features have changed by showing individual slices of time. So we can, essentially we're looking at a different slice of time across each one, allowing ourselves to be able to compare between the different times as we're looking at them. So here we see an example of this showing election results. You can see that there are different slices of time showing things that our eyes can follow across the maps. We can also do this for something like raster data, where we see vegetation indices compared over multiple different times here. Now, the last way that we can visualize data, temporal data in a GIS context or when we're creating maps is through animation. Now, obviously, when you're creating an animated time series map, you're going to be seeing essentially a video. So this allows us to show everything at once, to show all the different time slices that we might be interested in, and then animate them together into some sort of video. So obviously it's only going to work in a digital context. You can't print this out and have it mean anything at all. And it can be, depending on how you're viewing the video, difficult to focus on an individual slice of time. So these are not always the most applicable use of, or most applicable way to visualize temporal data. So here we see a time series video, an animation showing the different states and territories of the US from 1783 up until the modern time. So you can see that there are changes, we have them symbolized in different ways, and we're still able to show everything kind of as a video here. So when we're dealing with time data in ArcGIS, for vector data, we have integrated tools that we can use. We need to have them formatted in a particular way, but there are different methods that we can use to visualize temporal data that are sort of integrated in ArcGIS. Now in particular, what we need to have is we need to have repeated features instead of repeated fields. Now what do I mean by this? Well, essentially, each feature has to be repeated for each time series that there is. We can't just have a column that's 1980, a column that's 1981, a column that's 1982. We need to have a feature for 1980, a feature for 1981, and a feature for 1982. And this is so that we can show things like differences, like changes in the actual geometry of those features or the locations of them. So if we see here, this is an example of showing different time periods as different columns, as different fields. And what we need to have is we need to have it like this, where we have different features, individual features for each time slice that have either a start date or a start and end date for each one of the features. Now there are also ways that we can render and deal with raster data in ArcGIS. They're a little bit more complicated, and they use a type of feature or type of file called a netcdf. And this is not something that there's native support for in ArcGIS. We have to manually create a layer using the Arc Toolbox for this. And we'll go over this in some detail in the demonstration. But essentially what a netcdf is it's a raster image where there's one single layer of data. It might be precipitation, it might be temperature, it might be something like that. They're usually environmental data. And then there's a whole lot of different slices. So essentially it's like a 1,000-band image where each band is a time slice. So we have to trick the program to be able to display that in one band and then correlate all of the different ones with time. So this is what one of these might look like rendered as a video, where we can see the changes in each month in precipitation, shown as the colors, different colors here, where red is a higher precipitation and blue is a lower precipitation. So you can see the seasonal changes, you can see everything else put together into a nice little animation here. So there are a lot of different places where you can find already pre-rendered temporal data to use in ArcGIS. Now a lot of these tend to be vector data. There are two that are listed up here, the Atlas of Historic County Boundaries through the Newberry Museum, or Newberry Library, and the National Historic Geographic Information System. Both of these are pre-built layers showing county and state boundaries with some census data associated with them throughout the time in the US. There are similar institutions for other countries if you're interested in those. And then there are a lot of places to find climatic data, particularly for the last 20 years or so, but there are models that go back even further. And the best one of these is the National Oceanic and Atmospheric Administration, NOAA's website of gridded climatic data sets, the link for which is seen up here. So that's a little bit of an overview of time and temporal data. I want you to take away from this that it's possible to use these things to create animations, to create static maps, to really have your GIS layers time aware. But you do have to make some pretty significant choices in how you organize the data and how you create the vectors you're working with.